Greetings everyone, welcome to Cyber Hashira. Today I'm going to talk about an important topic in PKCS 11 called attributes. Every object in PKCS 11 has an attribute, and it's those attributes that determine what you can do with those objects. In this video, I will explain why and how to use attributes. Let's begin. Attributes are properties of an object, so before I start talking about attributes, I want to do a quick recap on objects. This information is mentioned on page 15 of PKCS 11 manual. Objects are cryptographic items that gets created or generated in a token. They are of three types: data object, key, and a certificate. A data object is an object which holds some information, for example, a seed value or a serial number. I'm sure you already know what a key and a certificate is. There are three types of keys: a public key, a private key, and a secret key. Objects in PKCS 11 can be identified based on how they can be accessed. They are public object and a private object. I am not talking about public key or a private key. Please don't get confused. I am talking about objects. This information is available on page 16. A private object can only be accessed after you have authenticated. So if there's a key which is set as a private object, you won't be able to access that key if you're not logged in. A private object cannot be accessed without first authenticating to a token. Access to a public key is allowed even if you're not authenticated. An object can also be identified based on their lifetime. A token object is also known as a persistent object. These objects persist in the token even after a session is closed or finalize is called. They continue to exist even after a token is disconnected or powered off. Session objects are ephemeral, they are temporary. These objects get destroyed after a session is closed or finalize is called. Disconnecting a token would also destroy these objects. That was a recap of objects. Let's now talk about attributes. Attributes are properties of an object. They help distinguish one object from another. Attributes also decide what an object can do and what they can't. Attributes in PKCS 11 are prefixed with CKA. Attributes are required when you want to generate, create, or unwrap an object. Attributes can also be used to adjust the security and access level of an object. Every object in PKCS 11 has an attribute, and those attributes can also be used to find those objects. Attributes are also required if you want to read some information such as label or a key value of an object. And these are some common attributes that I will be discussing in this video. As you can see, there are quite a lot of them. These are just half of what's mentioned in the PKCS 11 manual. I'm only covering these specific ones. The complete list of all attributes can be found on page 376. I'll start with CKA token. CKA token attributes indicates whether an object is a session object or a token object. Token objects persist, whereas session objects are short-lived. CKA token only accepts value of type CK-bbool or boolean. If the value of CKA token is CK true, then it means it's a token object. And if that value is CK false, then it's a session object. Moving on to the next attribute, CKA private. This attribute indicates if an object is a public object or a private object. As mentioned earlier, private objects requires an authenticated session and public objects don't. CKA private accepts a boolean value or CK-bbool. CK true marks an object as a private object, whereas CK false marks an object as a public object. The next attribute is called CKA local. If an object is generated within a token, then that object is referred to as a local object. It simply indicates that an object was generated inside a token. An object which was imported from outside is not considered a local object. For example, if you try to import a key which was generated using OpenSSL or some other utility, then that key is not local. CKA local uses a Boolean value or CK bbool. This value is set by a token when an object is generated, derived, copied, or imported into a token. The value of CKA local cannot be changed. CK true would mean that an object was generated locally or inside a token. And CKA false would mean that object was generated outside of a token. Next attribute is CKA class. It defines the type of an object. Detailed information about CKA class can be found on page 48. CKA class accepts value of type CK object class, which is an unsigned long data type. And these are the class types in PKCS 11. I'm sure some of them may sound familiar to you, like CKO certificate, CKO public key, CKO private key, and CKO secret key. Now, here's an example. An AS key would be of type CKO secret key because it's a secret key. An RSA key pair would have two objects, a public key and a private key, and they will be of type CKO private key and CKO public key. There will be a video soon where I will dive into more details about these objects. Next attribute is CKA key type. Now, I talked about CKA class, which only defines whether an object is a private key or a public key or a secret key. CKA key type is more specific. It defines which type of key is being used. Information about CKA key type is available on page 49. CKA key type accepts value of type CK key type. It is an unsigned long data type. And these are some of the key types. There are some familiar names like AES, RSA, DSA. A complete list of these key types can be found on page 375. I will be making a separate video where I will teach you how to use these types of keys. CKA sensitive attribute is used for marking an object as sensitive. When an object is marked as sensitive, crypto key will not reveal sensitive information about that key in clear. For example, if you mark a secret key as sensitive, you will not be allowed to read the value of that key. You will be allowed to use that key. CKA sensitive only accepts a Boolean value. If the value of CKA sensitive is true, then it means that the object is marked as sensitive. You will not be allowed to read sensitive information from that object. And if the value of CKA sensitive is false, then that object is not sensitive. You should be able to read all sensitive information about that key. Something you need to know about CKA sensitive attribute is that its value can be changed from false to true, but it cannot be changed from true to false. CKA extractable attributes marks an object as extractable. An extractable key can be taken out of a token using a technique called wrapping. There will be a separate video about wrapping and unwrapping. For now, just know that wrapping is used for extracting a key from a token. You can read about extractable on page 82. CKA extractable only accepts a Boolean value. If the value of CKA extractable is true, then the object is extractable. And if that value is false, then the object is not extractable. You can change the value of CK extractable from true to false, but you're not allowed to change it back to true. CKA modifiable attribute allows marking an object as read-only. Attributes of a read-only objects cannot be changed. Information about this attribute is on page 71. CKA modifiable only accepts a Boolean value, which is either CK true or CK false. If that value is true, then the object is modifiable. And if the value of CKA modifiable is false, then you're not allowed to change the attribute of that object. That object is read-only. CK modifiable only allows one-way change. You can change its value from true to false, but you're not allowed to change it back to true. I'm going to talk about CK encrypt and CK decrypt together. These are two separate attributes. CKA encrypt and CKA decrypt attributes define if a key is allowed to encrypt or to decrypt some data. CKA encrypt permits a key to encrypt, and CKA decrypt permits a key to decrypt. This attribute is useful when you want to control what a key is allowed to do. Both of these attributes only accepts a Boolean value. A key can encrypt if CKA encrypt is set as true. Similarly, a key can decrypt if CKA decrypt is set as true. Also, there is something that you cannot do because it's fundamentally wrong. You cannot set CKA encrypt attribute to a private key because a private key is used for decrypting data. Just like that, you cannot set CKA decrypt to a public key because a public key can only be used to encrypt, not decrypt. A key will not be able to encrypt data if CKA encrypt is set as false. Same goes for CKA decrypt. If it is set to false, then you will not be able to decrypt. And once again, CKA decrypt cannot be set to a public key. CKA encrypt cannot be set to a private key. Next two attributes are CKA sign and CKA verify. CKA sign permits a private key to sign data, and CKA verify permits a public key to verify signatures. Both of these attributes accepts a Boolean value. If CKA sign for a private key is set as true, then the private key is allowed to sign data. Likewise, if CKA verify is set to true, then the public key is permitted to verify signature. CKA sign set as false will disallow a private key to sign data. CKA verify set as false will disallow a public key to verify a signature. And don't forget, CKA sign is not meant for a public key and CKA verify is not meant for a private key. In cryptography, key wrapping and unwrapping is used to securely transport a key over an insecure channel. Essentially, wrapping means encrypting a key using another key. I will be making a detailed video about this topic, so for now, just know that CKA wrap and CKA unwrap attributes permit a key to wrap or to unwrap. The value of CKA wrap and CKA unwrap is of type Boolean. If CKA wrap attribute of a key is set to true, then that key is allowed to wrap another key. If CKA unwrap is set to true, then that key is allowed to unwrap a wrapped key. You can disable the ability of a key to wrap or to unwrap by setting CKA wrap or CKA unwrap as false. CKA derive permits a key to be used for key derivation. The value it accepts is Boolean. If the value is true, then it means that the key can be used to derive another key. And if that value is false, then the key derivation is disallowed. Next attribute is CKA never extractable. CKA never extractable is an informational attribute. It just tells if CKA extractable attribute of a key has always been false or not. This attribute helps prove that a key has never been extracted and can never be extracted. Information about this attribute is available on page 82. The value of CKA never extractable is of type Boolean. This attribute is read-only. The value of this attribute, true or false, is set by a token when a key is generated for the first time. You cannot manually set the value of your choice or change the value afterwards. If an object was generated with CKA extractable as false, then CKA never extractable will be true. And if that object was generated with CKA extractable as true, then CKA never extractable will be false. Another informational attribute is CKA always sensitive. This attribute tells us if a key always had CKA sensitive as true or not. This attribute proves that a sensitive information about a key was never read and cannot be read. Information about this attribute is on page 82. CKA always sensitive uses a Boolean value. This attribute is read-only. The value of this attribute is set by a token when a key is generated. You cannot set your own value or change this value afterwards. Value of CKA always sensitive will be true if CKA sensitive attribute has always been true. If the value of CKA always sensitive is false, then it indicates that the value of CKA sensitive has been false at some point. These are some commonly used attributes in PKCS 11. They are easy to understand, which is why I'm putting them all in one table. CKA ID has an information about a key such as a key identifier, a serial number, or a timestamp. Having CKA ID makes it easier to locate a key when there are too many keys in a token. This attribute stores information as a byte array. CKA label is used for specifying the label of a key. This attribute accepts value of type CK UTF-8 character. CKA modulus stores modulus of an RSA key. It accepts byte array as an input. CKA modulus bits is the size of an RSA key. Its value is of type unsigned long. CKA public exponent attribute stores the public exponent of an RSA key as a byte array. CKA value is the value of a secret key, data object, or a certificate. It stores data as a byte array. CKA value len is the length of a key in bytes. CKA EC params is used for passing ECDSA parameter or ECDSA curve ID as a byte array. CKA EC point has the ECDSA public key as a byte array. Let's now talk about CKA vendor defined. PKCS 11 allows hardware vendors to define their own attributes. These attributes are also known as vendor defined attributes. Information about this attribute can be found on page 50. The value of vendor-defined attributes starts with 0x800000 with an increment in value for every new attribute they define. A vendor may use these attributes for a custom feature or to help use a mechanism provided only by them. And because these attributes are customizations provided by a vendor, these may not work with other token vendors. So using these attributes may present some compatibility related issues. Now I'm going to talk about an important topic in PKCS 11 called attribute templates. If you are going to use a hardware token, then at some point you would have to use a template. You should have a good understanding on how to use these templates. So what are templates? An attribute template is simply an array of attributes. These templates are passed as an input into a PKCS 11 function. I'll talk more about those functions later in this video. An attribute template is made using CK attribute structure. You can read about CK attribute on page 51. I will talk about CK attribute structure soon in this video. If you were to generate a key, then by using templates, you can define the properties of a key. You can customize how you want that key to be generated and what that key is capable of doing. Templates are used when you want to modify some attributes of an object. Templates can also be used for finding an object, copying an object, and unwrapping an object. Let's now talk about CK attribute structure. As stated earlier, it's a structure. CK attribute has three components: type, value, and length. CK attribute type stores the type of attribute you want to define. These are attributes I talked about earlier. For example, CKA encrypt, CKA sign, or CKA token. CK void PTR is a pointer that points to a variable that has the value for that attribute. And CK ulong is the length of that value. Now let me show you some examples to make it easier to understand what I mean. Here's my first example of a template used for generating a secret key. An actual working template may have more values, therefore much bigger. I am using this short version as an example. Let's start from the top. At the top, I have defined four variables. The first and the second variable are of type Boolean. Yes has a value of true and no has false. third variable is obj class, which is of type ck object class. It has cko secret key as its value. I will be using this template to generate a secret key. Next variable is called length, which is of type ckulong. It has a numeric value of 32, which means I want to generate a secret key of size 32 bytes. And the remaining part is the template. I hope you still remember the structure of ck attribute. It is type, value, and size. There's a variable called attrib. It is of type ck attribute and it is an array. And the first attribute in this array is cka token. It has a value of yes, which means it's true, and it has a size of ck bbool. This means I want my secret key to persist in the token. The next attribute is cka private, which has a value of no or ck false. This means I want the secret key to be accessible to a user without requiring authentication. Next attribute is cka class. I am generating a secret key, so this object belongs to the category of secret keys. cka value len has the length of the key. I want this key to be able to encrypt, and that's why I'm passing yes for cka encrypt. And I don't want this key to be able to decrypt, and that's why I'm passing no into cka decrypt. No has a value of false. So just to summarize, I am generating a secret key of size 32 bytes, which should persist in a token. It can be accessed without authenticating. This secret key can encrypt, but it can't decrypt. I hope everything I talked about at the beginning of this video is finally starting to make sense. Let's have a look at one more example, an easy one to understand. And here's the second example. The purpose of this template is to find a secret key which can't decrypt. Let's look at the attributes I'm passing in this template. The purpose of this template is to find all secret keys in a token which cannot be used for decrypting. So cka token is yes, cka class is of type cko secret key, and cka decrypt is set as no. So I can pass this template into cFindObjectsInit function and tell it to find all secret keys in a token which can't decrypt. Lastly, I want to give a quick overview about some functions which takes attribute templates as an input. cGenerateKey is used for generating a secret key. cGenerateKeyPair is used for generating an asymmetric key pair. cCreateObject is used for creating an object such as a data object or a certificate. cFindObjectsInit is used for initializing a search for an object in a token. cGetAttributeValue is used for reading an attribute value of an object. cSetAttributeValue is used for changing an attribute value of an object. cCopyObject is used for making a copy of an object. It can also be used for changing some attributes as well. And finally, there's cUnwrap, which is used for unwrapping an object into a token. Alright people, that wraps up this video. Today you have learned about attributes, which is a crucial topic in PKCS 11. I wanted to cover attributes before delving into other PKCS 11 functions. Attributes will be used extensively throughout this tutorial. And as always, thank you so much for watching this video. I hope you found something new to learn. Please leave a like if you liked my content. Consider subscribing to my channel if you're new here. I look forward to seeing you in the next video. Goodbye and take care.